Hello, everyone, and people on YouTube. Today, we're going to presentate about our operating system funnel project called CPU Scheduling Funnel Project. So, our project will have the features using manual input for processes with fields such as PID, arrival time, burst time, and priority. And after that, we're going to use five scheduling algorithms. We were going to use five scheduling algorithms such as FCFS, SJF, round robin, priority scheduling, STRF, and the comparison mode. After we use the scheduling algorithm, we're going to generate random processes. And after that, we're going to visualize using the Gantt chart, with each process being color coded. And after finish showing the Gantt chart, we will compare using an automatic algorithm. And lastly, we're going to perform the statistic visualization on each five scheduling algorithms.
Alright, Devin already explained the features, so now Alan, I'm gonna do the demo for this program. So, as mentioned before by Devin, we can enter the processes manually. So, it will then ask you to uh, how ask you to input how many processes you want to simulate. Let's say 5. So then we're gonna have to click input one by one for the PID, the arrival time, the burst time, and priority if you use priority scheduling. But to save on time, we will try to use the other feature, which is to generate random processes. So we're gonna choose that instead. So let's say we want to have 10 processes randomly generated. As you can see, we have 10 processes generated with each own randomly generated arrival time, burst time, and priority. And we can choose which schedule algorithm we want. So we have 5 options, which is first come first serve, shortest job first, round robin, priority scheduling, and shortest remaining time first. Now we also have the ability to compare all algorithms at the same time. So for demo purposes, let's try to have it simulate round robin. As you can see, we'll also ask for the time quantum for round robin, which we will choose 2. Why 2? For no particular reason, because if it's 1 or lower, it's bad, but if it's too much, it's also bad. It will become FCFS if it's too much. So as you can see, it created the round robin scheduling with time quantum 2, as well as calculating the average waiting time and the average turnaround time. As you can see, it's 31.1 and 37.0 respectively. And we also have the Gantt chart for the process. But let's say we want to run all of them. So let's try to generate random processes. Let's create the 10 the same and compare all algorithms. As you can see, it will compare all the algorithms from first come first serve to short remaining time first. It also again calculates average time and average turnaround time and creates the Gantt charts. What with an added bonus of a bar chart comparing the average waiting time and average turnaround time of every algorithm. As you can see, round robin tops it with the worst average waiting time and average turnaround time, with first come first serve being third actually, while priority being second, while short job first and short remaining time first is even. Why this is actually explained in the report later on. That's it for our program demo. Thank you very much and goodbye.